Let's look at the bromination of a diene. Here, a diene, a compound with 2 double bonds, is brominated, and the bromination can occur at the 1 position, it's the compound I've shown in yellow here, or the 3 position, compound I've shown in green. Now, as these reactions go, there's an equilibrium here. So these two products can interconvert. The question I have for you is, given this data over time of how the reaction proceeds, can you deduce the difference in the reaction profiles? So here, the solid yellow line is the 1-bromo product, and the dotted green line is the 3-bromo. Notice that the 1-bromo is the same throughout, and I want you to tell me, how is it related to the 3-bromo reaction profile? Think about that for a minute and make a selection. Let's look at a possible explanation for each answer. A, the 3-bromo product has a higher activation energy, so slower kinetics, which also means a higher delta E, the difference between products and reactants. B, 3-bromo has a higher activation energy, slower kinetics, but is also favored over time, so it has a larger difference, delta E. C, 1-bromo has a higher activation energy, slower kinetics, and is favored over time, so a larger delta E. Think about those 3 and make a selection. We're looking at the bromination of a diene. It can be brominated in the 1 position or the 3 position, and we have some data about the chemical reaction. So as the chemical reaction occurs, initially the 1-bromo is favored. So it's kinetically favored. It has a short pathway or a low activation energy to forming relative to the 3-bromo. If you look at the reaction over time, though, as I go out to 4 hours, what's happening is the 3-bromo is building up in concentration. So over time, the 3-bromo is more stable, so it's more thermodynamically stable. So you have a kinetically favored 1-bromo and a thermodynamically favored 3-bromo. Well, kinetically favored means you have a lower activation energy. So we should look for a plot where the yellow solid line has a lower activation energy. So C is out. The thermodynamically favored means there should be a larger difference in energy between the reactants and the products. So if you look here, there's a smaller difference between the reactants and the products in the green than here in B. So B has the characteristics we want, a higher activation energy for the green, the 3-bromo, so it's slower to form initially, but a larger difference in energy between the products and the reactants, so it's more stable over time, more thermodynamically stable. So in this case, the correct answer is B.